These are solutions to Calc 2 exam number 2. Number 1, integrate x squared ln x dx. So there's an ln involved, so let that be u. dv is x squared dx. du is 1 over x dx. v is x cubed over 3. So I is u times v, 1/3 x cubed ln x, minus the integral of v du, take out the 1/3. 1 over x times x cubed is x squared dx. So 1/3 x cubed ln x minus 1/3 x cubed over 3 plus c. 1/3 x cubed ln x minus 1/9 x cubed plus c. Number 2, there's a polynomial and a trig, so let u be the x part. U equals x, dv is cosine 2x dx. du equals dx. V is half sine 2x. Integral of cosine is sine. And then you do the opposite of what you would do if you differentiate, which is multiplied by 2. Therefore, you multiply by half. So I is u times v, 1/2 x sine 2x, minus the integral of v du, 1/2 integral of sine 2x dx. Leave this alone, 1/2 integral of sine 2x is negative 1/2 cosine 2x plus c. So final answer, 1/2 x sine 2x plus 1/4 cos 2x plus c. Number 3, you've got cosine and sine and an odd exponent. So that's the best case of working this out. Let u be cosine x, du is negative sine x dx. So I becomes multiplied by negative 1 inside and outside. So after you substitute, you get negative u squared du, negative u cubed over 3 plus c, negative 1/3 cosine cubed x plus c. Number 4, tangent squared, you want to think of it as secant squared minus 1. And the integral of secant squared minus 1 is just tan x minus x plus c. Okay. Number 5 was probably the longest and trickiest one, so much so that I messed up the first time I did it. Integral of x cubed radical 9 minus x squared dx. So let x be 3 sine theta. dx is 3 cosine theta d theta. So x cubed becomes 27 sine cubed theta. 9 minus x squared, 9 minus 9 sine squared theta. dx is 3 cosine theta d theta. This factors into 9 times 1 minus sine squared. The next step, this will become 9 cosine squared theta, whose square root is 3 cosine theta. So that gets rid of the square root. So 27 sine cubed times 3 cosine theta times another 3 cosine theta. 27 times 3 is 243. Sine cubed cosine squared. Again, there's an odd exponent, so change sine cubed to sine squared, cosine squared times a sine theta d theta. Make this have only cosine, so 1 minus cosine squared theta, cosine squared theta, sine theta d theta. So u equals cosine theta, du is negative sine theta d theta, 1/2 inside and outside. Negative 243, 1 minus u squared du. So this comes u squared minus u to the 4th. Put the negative back inside to get rid of the negative. U to the 4th minus u squared. So 243, u to the 5th over 5 minus u cubed over 3. And change u back to what it was. So 243, 1/5 cosine to the 5th theta minus 1/3 cosine cubed theta plus c. Now x is 3 sine theta, which means sine of theta is x over 3. Draw my triangle. Opposite hypotenuse. Peek back to the original. Radical 9 minus x squared. But again, a quick double check would not be wrong. This thing squared is 9 minus x squared. This thing squared is x squared. Add them up, you get 9, which is 3 squared. Okay, so just change every occurrence of cosine theta to this, radical 9 minus x squared over 3 adjacent over hypotenuse. So finally, 243, 1/5 radical 9 minus x squared over 3 to the 5th power minus 1/3 radical 9 minus x squared over 3 to the 3rd power plus c. Problem number 6. This one from the chart, the only one that had a plus was tangent. So x is 3 tan theta, dx is 3 secant squared theta d theta. So dx is 3 secant squared theta d theta. Radical x squared is 9 tangent squared plus 9. That factors into 9 times tangent squared plus 1. Tangent squared plus 1 is secant squared. So the square root of this is just 3 secant theta. 3's cancel out, secant cancel out. I'm integrating secant theta, which is ln absolute secant theta plus tangent theta plus c. And now we're told that x is 3 tan theta. So tangent theta is x over 3. Opposite adjacent. Peek at the original, you're probably correct. Radical x squared plus 9, but a quick double check. Is a squared plus b squared equal to c squared? Yes. X squared plus 3 squared is 9, which is equal to this thing squared. So we have secant theta, which is hypotenuse over adjacent, radical x squared plus 9 over 3, plus tangent theta, which is x over 3, plus c. I accept that, but I talked about this in class. The best, absolute best to write it is lose the 3, because you can think of as ln of that over 3, which is ln of this minus ln 3. Minus ln 3 plus c is still plus c. And I talked about this in class. This expression can never be negative. So switch it back to parentheses. So ln parentheses radical x squared plus 9 plus x plus c. Number 7. Okay, the denominator factors in x squared times x squared plus 4. So you have a repeated linear factor. So a over x, b over x squared, and x squared plus 4 being an irreducible quadratic, cx plus d over x squared plus 4. Number 8, do the partial fractions. X minus 8 over x minus 5, x minus 6 is a over x minus 5 plus b over x minus 6. Multiply this fraction by x minus 6 over x minus 6. Multiply this one by x minus 5 over x minus 5. So you have the common denominator. And you have this stuff. Multiply out the top, ax minus 6a plus bx minus 5b. Gather like terms, a plus bx plus negative 6a minus 5b. And I have to set it equal to the original, which is 1x minus 8. So therefore, a plus b has to equal 1, and negative 6a minus 5b is a negative 8. I multiply the top equation by 6. There's other ways to do it. That gives me 6a plus 6b equals 6. Add them up. B equals negative 2. Plug back in here. And a is 3. So the original, a and b are now 3 and negative 2. So I'm integrating 3 over x minus 5 minus 2 over x minus 6. So that's 3 ln absolute x minus 5 minus 2 ln absolute x minus 6 plus c. Number 9, trapezoidal rule only. You have a very nice delta x. 5 minus 1 divided by 4 is 1. Trapezoidal rule, 1 here, 2, 2, 2. So delta x over 2 is 1/2. 1 times f of 1 plus 2 times f of 2 plus 2 times f of 3 plus 2 times f of 4 plus 1 times f of 5. The 1s means the numerator is 60. The 2s will make all the numerators 120. So 60 over 1, 120 over 2, 3, 4, and then 60 over 5. These are all nice whole numbers. 60 plus 60 plus 40 plus 30 plus 12. So 1/2 of 202, which comes out to be 101. And a side note, if you actually integrate, you get 60 ln 5, which is about 96.566. Okay, number 10, integral from 0 to 1 of y equals 1 over radical x. Function is not defined at 0, but if I move a tiny bit to the right, I can call it b, and I can integrate from b to 1, and then take the limit as b approaches 0 from the right. So I want the limit, I as the limit as b approaches 0 from the right of the integral from b to 1 of 1 over radical x, x at negative half dx, which is limit b approaches 0 of x to the 1/2 divided by 1/2 means times 2 from 0 to 1. Take out the 2. X to the half means square root. Limit as b approaches 0 from the right of radical x from b to 1. Plug in 1, I get 1. Plug in b, I get radical b. And when b approaches 0 from the right, this approaches 0. So I have 2 times 1. So the answer comes out to be 2. Right, so these are solutions to exam 2 of Milham's Calc 2.